To this 5-minute tutorial on how to configure RPKI ordinary validation on a JUNOS device. So the first thing you need to configure OV on a JUNOS device is obviously a JUNOS device. You also need a validator of some sort. So let's start at the validator. So one of the quickest way I could find out to kind of get a validator up and running is to, in this case, using an AWS instance, T3 large running Ubuntu. The standard version. It has been up and running for about an hour. I just started this to kind of make sure the video could be short and we just focus on the important bits. So it has a public IPv4 address, and I installed Routinator from the package manager using the standard Routinator kind of tutorial. So it's completely default install. It has no special things, just straight from the box, 2-minute up and running, and then of course kind of started the validation process. So just to look at this, so we have a Routinator that was started 1 hour and 16 minutes ago. No configuration, just go. So what this is doing, so Routinator has started. It is downloading the ROAs from the different repositories using rsync or RDP. There's always a couple of these that fails for some reason. Maybe the repository is not reachable or so. That's fine. That will always happen. And it is spawning an RTR server that our router can talk to. So looking at a router, I do have MX204 running JUNOS 18. It is an active and live router in a actual production environment. It's peering on an IX with over NetNode Stockholm with a route server. So the first thing we need on this box is to set up an RTR session towards my instance here in AWS using this IP address. So I have prepared this just to make sure we have fresh data to always look at, so we don't need to wait for things to kind of come in. So here we have the RPKI validator, so a session towards this IP address. It is using the standard RTR port, so 3323 has a local address. This means that session has been up for, in this case, 1 hour. It has downloaded somewhere north of 200,000 IPv4 records and about 40,000 IPv6 records. This means that the ROAs are now in this Juniper box, and these ROAs can be used to produce a validation state. So what we need here is some kind of policy that sets the validation state on an inbound on an eBGP session. So if we look at a policy that I prepared here, this is obviously your policies will most likely be more advanced, but in this case we're only looking at the OV configuration part. So we have 3 terms. The first one looks for validation state invalid, or rather it looks in the database. If it deems that the prefix is invalid, it will set the state to invalid and reject it. Term 2 will look for valid ones, so it is looking in database, searching for valid prefixes, which means that there is a covering ROA and it is the same as it gets on the inbound session. In this case, I'm also setting local preference. This is only to make sure I could do this elaboration in production without disturbing anything else. So other peers have local preference of 100. So I don't program any routes from this route server session. So that's the only reason. Otherwise, I would not suggest to program local preference as part of the OV process. Either way, so it looks for valid, it sets the state to valid, and it sets to accept. Term 3 does the same thing for unknown. So it looks for unknown, it sets the state unknown, it sets the same local preference as valid, and accepts it. So I think the most important bit here, whatever local preference you have, I would suggest to never distinguish between valid and unknowns. Just have them at the same local preference level, and then you straight up drop the invalid ones. So okay, so this is the bare minimum policy you need to perform origin validation correctly. So if we look at the BGP configuration, we can see here we have a NetNode peer. So what we do is that we reject all, in this case, yes, while we're doing the labs. So we have a single neighbor. This happens to be the route server using a peer AS 52005. And if we look at this session, we can see that we get about 100,000 prefixes from this. There's no active ones given the local preference we set. And what we can do here is to kind of see these different states now. So it has the React all export, and it only has this newly created RPKI OV policy on the inbound. So if we'll look at what we get from this peer, we can start by looking, for example, at valid ones. So this sets the validation state valid, looks for everything that comes in as deemed as valid. So all of these prefixes has the correctly covering ROA, and the router is happy to accept these, of course. And all of these prefixes are now also protected by the OV configuration we just did, which means that if someone else announces these prefixes with the wrong ASN or the wrong netmask, we will drop it if there's no corresponding LOA. We can make a quick check how many of these are actually valids. So remember, we got about 100,000 or so routes on this session, and 36,000 of them is valid. So that's actually great. A lot of these prefixes are covered by ROAs. We can look the same for unknowns. Same type of prefixes, so there's no ROAs for these, but we still accept them, of course. We can make a quick count, see how many of the prefixes on this route servers are unknown. I would assume around 70,000 or so, given that there shouldn't be many invalids coming in over these route servers. So yeah, it's a pretty good guess, 70,000. And if we want to look at the filtered ones or hidden ones, we need to look for hidden routes, which on Juniper language is the filtered ones. So hidden ones and validation state invalid. Remember, we do not have any other type of inbound policy on this peer, so we only look at validation state. So typically you would probably have something that filters small routes or RFC 1919 and these kind of things. The route server in itself most likely have a lot of filters as well, but some things always get through, I guess. So these are the invalid ones. So these are either active hijacks or misconfigurations or whatever it can be. Like for example, we see a couple of /32s coming in here. Most likely there is no ROA for these ones on a /32, so maybe the ROA is created for a /24 or some larger prefix instead. And they're trying to do something here, but we are blocking it, right? So all of these are currently blocked. We do not accept these routes. So either way, that was about 5 minutes, and this router is doing correct origin validation. And it is quite easy to set this up on a JUNOS device, so feel free to use this information and go ahead and configure OV and join the club. Thanks.